All right. So here's what we have to do. I have to somehow prove that there is such a thing as an addition angle. And the one I'm going to pick on is the cosine. Now, Michael, if you're with us, I know as I wrote the lecture, I thought he's gonna give me trouble about this. But I'm gonna pick cosine, okay? And then I promise if you let me pick cosine, I can get you the rest. Okay, now why would I pick cosine? It's a hunch. It's a hunch that that one's gonna work. Okay, but what we're gonna try to find is that let's say there's some angle one, some angle two. Okay, we're gonna try to find, well, what if you added those and took the cosine of it? Okay, that's my goal, is to come up with that formula for you. And then once you have that formula, you can go off and become engineers. Okay, you'll be ready to go. All right. We're gonna pick on cosine because it turns out it's easier proof, so that's why we pick it. But if we pick that one, the rest come in line. Okay, so we want this magic formula where we can do cosine with addition angles. Let me just show you real quick our goal. Okay, I want to be able to say the cosine of pi over 3 plus the cosine of pi over 2. I know both of those. I know both cosine of pi over 3. I know cosine of pi over 2. What should that be? What would that equal? That's what we need. We need a formula that does that for us. Okay, that's our goal. Our goal is to be able to do that. And then if we develop a formula that can do that, we can start finding angles that we don't know. And that would be really nice. Okay. So if we could start finding angles that we don't know using addition and subtraction, well, there wouldn't be much that could stop us then. Okay. So we're also going to find cosine of 2 times the angle. We're going to find a formula for that. These are our goals here of what we're going to do. Okay. But the first one I do, I have to do through kind of a geometry problem. Right. So that's my goal, is to find what are these um, formulas and what would they buy us? They would buy us a whole new operations that we could do. Okay, so I'm going to set the stage. Here we have a circle. It's just the unit circle because we know that once we use the unit circle, we can expand beyond that. If you let me use the unit circle, then I can give you circles that are not of radius 1. All right, but here, let me just show you what it is we're thinking about, and then I'll show you the proof. So we're going to start right here with Q1, okay? Q1 is just some point. It could be pi over 4. It could be somebody else. It doesn't have to be any. It's a general point inside quadrant 1 on the unit circle. So that's who Q1 is, okay? Q1 is some point in quadrant 1, okay? Quadrant 1, it's just some point. And it has some x value and some y value. And those x values would be cosine of theta, whatever the angle is, and then it would also be the sine of theta, whatever that angle is. Okay, so that's who Q1 is. All right, so that's Q1. Let's meet P naught here. So let me introduce my friend P naught. P naught is a particular point that we've played with a lot. That is the point on the x-axis that intersects the unit circle, and the x-axis is the intersection point. And so that's just 1, 0. That's who P naught is. Okay. The difference between those is what our book calls it T. Other books call it other letters. It's fine. But it does have that distance T between them. Okay. So between them, there is this arc length of T there. Right? So that's who P naught is. That's who Q1 is. Okay. Let's introduce P1 and Q naught and see who they are. Okay. So first we're just meeting our main characters. So Q naught, trying to remember where the dead spot is on this. You can see Q naught is all the way down here. This is Q naught, and it's a distance of negative s arc length on the unit circle from P naught. So if you go from P naught, it goes all the way down negative s on the unit circle to get Q naught. That's another way to think about it. And then you could also think about it, let's switch colors. You could also think about it as t plus negative s. That's also the distance. Okay. So just setting up what's going on. Haven't proved anything, just kind of breaking down this diagram that's in the book. Okay. So that's who Q naught is. It's down here. Okay. Down here in quadrant 2. Let's just write that down. Let's not worry about what its sine and cosine is right now. Let's just say that Q naught is in quadrant 3. Okay, that should be good enough for now. And then let's talk about who P1 is. Okay, P1 is in quadrant 2. Okay, and what it looks like, it's an S away from Q1. Okay, so to me, it looks like it's Q1 plus S, is how it looks to me. Or you could go P naught and it's S plus T. So that's what's going on right here, is that you see this length is S plus T. Okay, this is the diagram in the book that sets up the whole chapter. Okay, so that's who we're talking about. Okay, let me clear this up so you can look at it more clearly. So we have 4 points: P naught, P1, Q naught, Q1. They do not have to be called this. Okay, they don't have to be called these letters. It's not always Q1 and Q2 or anything like that. But what we're setting up is, what we're trying to get to is that, is there a way to say what S plus cosine of S plus T is? If we could do that, we'd really have something. That's our goal, is to find this addition formula to be able to do this. So we're setting this up where you see from Q1, the angle plus S right here gets you to P1. So here is that angle plus S. That gives you P1. Okay, so, or you could go P naught would be S plus T. That's the idea. All right, so that's what we're looking at here. So starting at P naught, terminating at Q1, P1 and Q naught, the coordinate P naught 1, 0, P1 is cosine S plus T. Let's see that. Cosine S plus T sine S plus T. Okay, let's make sure that that makes sense. Where's P1? Right here. This is P1, okay? And they're saying if P1 is the point 1, 0, then P1 is cosine S plus T sine S plus T. Okay, that's what they're saying. They're saying that Q naught would be cosine minus S sine minus S. That's not a 5, that's an S. Okay? Again, this is the only one I have to do it like this, but this sets up the rest of the week. Okay, so that's who Q naught is, right? It's going this way, negative S. Okay. All right, and then Q1 is in quadrant 1. Let's do green. Q1 is just cosine of T sine of T. Normal stuff. Okay? It could be pi over 3. It could be pi over 4. We're just saying it's T. Could be anybody. It's in quadrant 1 though, okay? All right. So that is our cast of characters. That's the diagram we're looking at. We haven't proved anything yet, but that's the idea. That's who we're looking at and what the goal is. The goal is to come up with some formula like cosine of theta 1 plus theta 2 equals blah, blah, blah. If we could do that, then I claim we can find sine, then I claim we can find tangent, and we're golden, okay? So that's the goal. That's our goal. Yeah. What was the next step? The next step, since cosine, okay, since cosine of negative s is equivalent to cosine of s. Does that make sense to you? Let's be sure that that does. Over here, if we have some point and we have some corresponding point here, they have an equivalent cosine. Okay, the plus or minus sign wouldn't matter, right? This angle going down, this angle going up, it will have the same cosine. So that's a property of cosine. It's on the right-hand side of the y-axis, so it's over here. So that would be equivalent, okay? We need that for our proof. The sine, as in sine function, the sine of negative s would be equivalent to minus sine s. And let's see if that's true. If I'm over here and I'm down here, they would be equivalent but opposite signs, plus or minus, right? The one up top in quadrant 1 would be positive, the one down there would be negative, okay? They're the same value, right? We looked at that with the unit circle. They're the same value, but they have the opposite sign, okay? It's confusing because it's called the sine function, and then I'm saying opposite sign as in plus or minus. Okay, so it follows that Q naught cosine S minus sine S. So we can say that. We can say it would be minus sine S. It's the same value, but it's opposite sign because one's in quadrant 1 and one's in quadrant 4. Okay, note that P naught and P1 are in between Q naught and Q1 and are equal. Okay, this is a big leap, but let's talk about it. So a big giant leap is that these are equivalent, these distances. That the distance d P naught P1 is equal to the distance of Q naught Q1. And that statement or that understanding, that giant leap, it wasn't my leap. Okay, I can understand the proof, but it certainly wasn't mine. That leap, that's the distance, and that we could set those equal to each other. That's going to be everything for us. Okay, so P naught. Let's clear out some stuff and look at what we're talking about. P naught P1, E naught, and P1. Okay, is S plus T. So this is S plus T. Q naught Q1. Let's change colors. Q naught Q1 S plus T. Okay, but those distances are the same. Okay, those distances are the same. You can't really tell by my drawing, but they are, okay? Or they are in this ideal world, right? So, does anyone remember that distance formula? It's coming up. I think we went over that like the first week or something. It was way back when, right? I think we were in 1.9. I think we were still in the first chapter when we did that. It's something like the distance between point A and point B. It's just Pythagorean theorem rewritten. but you could do x2 minus x1 squared, y2 minus y1 squared. Okay, that's the distance. Okay, we need the formula for the proof. Okay, so there we have our distance formula. We learned it way back when. It just comes from, that's just the hypotenuse of the triangle, the two distances. Okay, so that's where that's coming out. But the fact that we could set these equal to each other, these distances, if we can set those equal to each other, we might have ourselves a formula here. Okay, but note, we also have our points, our x values. These are cosines, right? That's a cosine, that's a cosine, this is a sine, this is a sine. Okay, so it's way more complicated than our algebra days, but that's what we're doing. Okay, so we're going to have a distance formula, but we're going to have that distance formula with trigonomic values. Okay, again, this is the only one I have to do this like. Okay, and I know it's frustrating when you have to go through somebody's proof, but that's the idea. Okay, so I've tried to set up our next stop is what's going on with that distance. Let's see if I can get the computer to cooperate. Okay, so I set up the distance formula. There it is. Here is our distance formula set up with those values. Okay, so we see cosine of s plus t minus 1. This is coming from P naught and P1. Okay? S plus t. So P naught, remember P naught was just, it's written up there too. It's just 1, 0. Okay. And P1 is cosine of s plus t, sine of s plus t. Okay. So this is P1, which is cosine s plus t, sine s plus t. That's who we're finding the distance between on that. Okay. So that's our distance formula. Those values are plugged in. Now we have the distance formula on the left-hand side of P1 and P naught. Okay, so we've set up our left-hand side. The right-hand side has to do with Q1 and Q naught. So this is the distance between Q naught and Q1. Okay, so remember that Q naught is negative s. We talked about that. So we have cosine of negative s, but wouldn't that just be cosine s? And then sine of negative s would be equivalent to negative sine s. Equivalent to that. And that makes that positive. This changes that sign right there, makes it positive. And then Q1 is just cosine and sine of t. So we have that. All right. We've set those distances equal to each other. Okay. And when you set those equal to each other and we have variables floating around, okay, that means we're just about to get ourselves a nice formula. Okay. We have to do algebra on this trigonomic equation, but we might have ourselves something. Okay, so we set those equal to each other. Those two distances are set equal to each other. We have to, that's where the square root comes from Pythagoras. We set those distances equal to each other, and now we have this big long expression. Okay, what we want to solve for is some trigonomic values here. Okay, so let's go to the next slide. All right, so I did squaring both sides. So I just squared everything. So let's just square this side is equivalent to squaring this side. So I squared those, squared them both, okay? And then for your notes there, I also expanded that out because I need these steps. So I've expanded those out as well, right? We have cosine of s plus t minus 1. So I've written it, pre-written it for us. S plus t minus 1. Think back to a minus b squared is a squared minus 2ab plus b squared, but now it's cosines of s plus t. Okay, so that's what I did. That's how I got to the next step. So from here to here, I've expanded it out. That's how I got that. So once I have that, what do I have? Okay, so I have cosine squared s plus t minus 2 cosine s plus t plus 1. That comes from here, here. It's this part, all right? And then we have sine s plus t minus 0 squared. That's not too bad because minus 0 doesn't change anything. So we just have sine s plus t squared. So now we have that. All right, so that nearly came for free. That's the left-hand side of the equation. Then we have cosine minus cosine squared. Let's change colors. So I have cosine t minus cosine s squared. What's that equal? That's cosine squared t minus 2 cosine t cosine s plus cosine squared s. So we see that's there. That was right here. And then lastly, we have sine t plus sine s. So sine t plus sine s squared, very similar, except there's a plus sign. So we have sine squared t plus 2 sine t times sine s plus sine s squared. We see that it's right there. Okay, that's what the distance formula bought us. I expanded it out. We see each and every one of those terms. And then we have to think, or at least I'm starting to notice and also recall more things about Pythagorean theorem. I know that sine squared of some angle plus cosine squared of some angle equals 1. That could simplify things quite a bit as long as we have the same angle. Okay, I can't mix and match, though it would be nice. I can't. So if I do happen to have something like sine squared s there, and if I had a cosine squared s, that might simplify. It looks like I have one right here. So that would turn into the number 1. That might be a way to simplify that expression. Okay. If I had a sine squared of s plus t, intent, if I happen to have that, s plus t plus cosine squared of s plus t, well, that would equal 1, and that sure would be a lot simpler than what I have currently. And I see that I have that right there. Okay, so I seem to have that right there. Well, that would simplify things. What if I had a cosine squared t plus a sine squared t? Then I could turn that into the number 1. And that sure would be simpler than what I'm looking at here. Let's change colors. So cosine squared t plus sine squared t equals 1. I see those friends there, so that's another 1 I can find. And the rest I might be stuck with. I also noticed that there is a number 1 there anyway, but that would simplify it quite a bit than where we're at. Let me clear that. We'll go to the next line. Okay, so by sine squared theta plus cosine squared theta equals 1, we can reduce it down to this expression. Okay, so I used Pythagorean theorem to be able to do that. And once we do that, we're kind of, I don't want to say stuck, but we're here. Okay, this is where we end up after we've made those alterations and found all the values and cancel all that we could. So we use the Pythagorean theorem of sine squared plus cosine squared equals 1 on the unit circle. And so now we're on this. Okay, so now we have this. All right, what is this? 2 minus 2 cosine s plus t equals 2 minus 2 cosine s times cosine t plus 2 sine s times sine t. Doesn't look like much, does it? What is my goal? My goal is to have a formula or expression that I can have addition of angles and cosine. That was my initial goal, okay? So what I did was I subtracted 2 on both sides. That's not too esoteric there. If I subtract 2 and subtract 2, solve for cosine s plus t. There we go. Cosine s plus t equals this. So the cosine of s plus t, angle plus angle, equals the cosine s times cosine t minus sine s times sine t. Okay, this is the formula that we're looking for. Okay, and I'm going to take a moment for applause. I know you guys are so excited to find the formula, and there it is. Okay, so that's what we're looking for. What does that mean? Okay. Our goal here was just to have some expression where I could have some angle plus another angle. And now I do. And now we can start playing with that. And it turns out there's a week's worth of consequences that come along with that. Okay. So this is cosine of the first angle, cosine of the second angle, minus the sine of the first angle times the sine of the second angle. Just for funsies, would you guys like to see an example of something we already know so we can kind of get a feel for how this works? So let's just pick some angles that we know. Let's pick some results that we know. That shouldn't be too hard. We know quite a bit about the unit circle. And then we could see how this formula works. And if it works that way, then maybe it'll buy us even more, okay? It's possible that if I just went back in my slides, I would give myself some more room. Good, big. That's not quite right. All right, once again, I'm confused by the computer. Why are we doing that? Do that. Okay. Okay, let me clean this up. Clean up my mess. Okay, so I think that the cosine can't even spell 3 letters. Cosine of theta 1 plus theta 2 is the cosine of the first angle, the cosine of the second angle, minus the sine of the first angle, sine second angle. Let's pick a value that we know everything about, and that way we can actually test this thing out. Okay, so I just want to pick some values that we know by heart, and then we can pick this out. So let's do first quadrant because that's easy stuff. Okay, let's think of a couple. We can even do a couple examples of this. How about pi over 4? That's always easy. We could do pi over 4. So if we looked at this, right, and if this was pi over 4 right there, we know all the values for pi over 4. We could add another pi over 4, I think. If we added another pi over 4, we should get pi over 2, and we know what that looks like. And so we could see, what does this equal? So that's my goal, or that's what I'm thinking we could show this as an example. Root 2 over 2, root 2 over 2, okay? And we should get 0, 1. We should get 0, 1. So this should demonstrate how this works. It should. See if it does. Okay. What would be the cosine of pi over 4? Pi over 4 is the cosine pi over 4, cosine pi over 4 minus the sine pi over 4, sine of pi over 4. Okay. What is the cosine of pi over 4? Oops, I don't need to write cosine anymore. Root 2 over 2. Okay. What does that equal? Root 2 times root 2 is 2 fourths. It's 1/2. 2 fourths, 0. Wow, what an amazing result. I used my new fancy formula to demonstrate that the cosine of pi over 2 is 0. Okay, but that's what the formula starts with. We could also show we could do pi over 3's, pi over 6's. Let's see how that works. Okay. Pi over 6, pi over 3, pi over 6, pi over 3, pi over 6, pi over 3. Cosine, cosine, sine, sine. We have to remember there's a negative sign. Do we remember the values of those? Here. We'll go here. And it should equal pi over 2, right? 2. Okay. So this is 1/2 root 3 over 2. This is root 3 over 2, 1/2. So there you go. Okay, so what's the cosine? Whoops. It is now the scheduled time to delete all files. All files stored on your flip and current roll will be deleted. Do you want to continue?
Okay.
Micah, did you have a question?
If you leave, what about mom? Just open the door, let him chill. I'm not gonna be here for very long. I'm just getting some food and I got food. Hey guys.
Hey, Micah, do you know your microphone's on?
Oh, I'm sorry about that, sir.
Joel. Okay. Which one was it? Cosine of pi over 6, root 3 over 2. And cosine of pi over 3 is 1/2. The sine of pi over 6 is root 3 over 2, and cosine of pi over 3 is 1/2, and 0. I've once again confirmed it's 0. Okay. Cosine of pi over 2 is 0. Cosine pi over 2 is 0. Confirmed. Michael was confused. You were very confused. I was very confused. Okay. Do we see how the formula works, Michael? Now that it's been derived? Oh, the audio trip to you. Oh, okay. All right. I mean, the proof, well, the proof's in the pudding, but proof's kind of hard. But I swear, once we have this, we've got something. We've got something in our notebook now. Because the rest I can't actually find. And we know from before that sine and cosine are almost the same thing. There's just a phase change. So we know that they're closely related. But once you have this, you've got something. So we just have to remember this. So that if you got something out of any of this, let's remember you could call it A. You can use any letters you like, any symbols you want. You could do a triangle and square or circles if you want. But the cosine of some angle, we could call it A and B if you want. It's the cosine of A, cosine of B, the sine of A, the sine of B. Just have to remember that. Cosine, cosine, sine, sine, but we have to remember the negative sign in the middle. Okay. If we have that, I claim we have something. We've got something now. Okay. All right. So please have one of these versions written down for your notes. The whole point was to get that. If we have that, we can move on and find more formulas. Okay. And then once we have all these formulas, then we basically have a new way, a new algebra. Wouldn't that be something?